Hi, all, and welcome to Racsinfotech. In this video, I'm going to share you a couple of Oracle ASM related interview question and answers. Okay, these are most important as and when you're going to face the interviews. Few of the questions you may get it. Okay, first question: what is the use of ASM? That in that way also they used to ask, and another way, why ASM? Why we need to use ASM? In that way also they used to ask, right? So for this answer, you can give it. For ASM, if you want to use it, okay, automatic storage management abbreviation. If you want a full form, if you want to know ASM, automatic storage management, it will provide the automatic load balancing overall, all the available disks and all. Okay, thus reducing the hotspots in a file system and preventing the fragmentation of the disks. Disk fragmentation and all those things is it is going to avoid it. Okay, it is going to improve the performance. So you don't need to manually reallocate the data or tune the IO performance and other things. Compared to normal file system where you're going to use it for your storage, ASM is a better because it is going to take care of it. It will prevent in the fragmentation and all is not required. And adding the disks is straightforward, and managing the disks also it is very easy. That's where we are going to use it. If you want to speak in high level or 2 or 3 words about ASM, why we need to use ASM will give you the better performance, and also it is going to give you the striping and mirroring. But striping and mirroring we are going to discuss later on a few of the questions. Okay, storage also, if you want to use high level of or huge storage, ASM will give you the more flexibility. So use the redundancy features available in intellectual storage arrays. The storage system can be stored all types of database files. So these are all the features which is given by the ASM. That's why we are going to use it. Okay, straightforward ASM we can use it for the high performance, flexibility, and availability kind of one, and also it is going to provide the automatic load balancing over all the available disks and all. Okay, the next question. What are all the init parameters related to ASM? Suppose you are going to use non-ASM file system, there you used to have different parameters inside of your init.var file or init file. Okay, but in case if you are using ASM, what are all the different parameters where we are going to use it? These are all the high level of parameter where we are going to use it. Okay, you can give instance type ASM, and the power limit is 11. 0 to 11 used to mention. We'll discuss separately what is mean by this power limit and that. And the ASM disk string, what are all the locations where we are going to give it. And the disk groups, what are all the disk groups you are going to create it and you are using. So these are all the different or specific ASM related parameters. This is the second question. So third one, what is rebalancing? Or what is the use of ASM power limit? As I said, right, we have this power limit. Give me 1 second. Previously, we discussed it, right? ASM power limit. Here it is. One of the parameter we have given the limit of 11, right? For this, here it is. What is rebalancing and what is the use of ASM power limit? Rebalancing, I'll talk about clear cut in separate question. But one of the parameter where we are going to use it to do the ASM rebalancing. One of the parameter is ASM power limit. Okay, this ASM power limit is a parameter. It's a dynamic parameter. This will useful to rebalance the data across the disks. If you are using multiple disks in your ASM disk group, who will do the rebalancing? This ASM power, based upon this ASM power limit, the rebalancing will be happen faster. If you are using value is lowest one, the rebalancing will be slower one. If you are using level is the highest level parameter value, rebalancing will be the faster, but conditions will be applied. If you are using high value, right, the performance will be depends on it. So according to your server capability, you have to define these things. Okay. Next question. What are the different types of redundancies in ASM? And explain it. If somebody will ask you the same question, right? We are having normal redundancy, 3 types of redundancies in ASM. Okay, 3 types of redundancies. Those are normal redundancy, high redundancy, and external redundancy. 3 types: normal, high, external. So for normal redundancy, external external redundancy. For normal redundancy, it's a two-way mirroring. Require two failover groups. For external, there is no failover groups, like not using for mirroring purpose. We don't have any mirroring, only striping will be available in the external redundancy. For normal redundancy, you are having two-way mirroring. High redundancy, you require three-way mirroring. Three failover groups, we are going to use it. For normal redundancy, two failover groups. This one, we are going to use it only one, what I can say, ASM disco group. Okay, there is no failover concept in external redundancy. Suppose I want to give you this. This is my ASM disk group. If you are using external redundancy in your system, okay, EXT, external redundancy, whatever the data you are going to write it, this in this disk group, right? This disk group data will be stored. So there is no failover related things. If something goes wrong, this disk group is not available. At that time, data will not be there, right? We have the complete downtime. The data also we are going to lose it. In case of normal redundancy, we are going to maintaining two groups. Two failover groups, something you are going to write the data it here. Whatever the data you are writing, option A is the data, I have written it here. The same will be stored into this failover group. Suppose this group one is failed or not able to accessible. The data is available from the disk group 2. This is called failover. And high redundancy, if you are using high redundancy, we are using three failover groups. Okay. 1, 2, 3. You have entered or written the data A. This A will be stored it here and here. So if this disk group is not available, the data related to A, right, that will be available from here and here. You can able to, even though it is not available, you can access it from here. Very high redundancy we are having. Redundancy means duplicate of your data. Okay, simple. So in external redundancy, you don't have any duplicate of data. Whatever the data you're going to write it, that data only it will be available. There is no redundancy. And normal redundancy, you're going to use it. One failover group extra will be there, right? One mirroring, one striping, one mirroring. There is no mirroring concept in your external. And the same way in high redundancy, you are having one mirror. So one striping, two mirrors. Two mirroring, two copies of the same data. It will be stored in different disk groups or failover groups. That is the concept. Okay. Next question. When you will use external redundancy and what are all the advantages? Suppose, just now I have explained, right? In external redundancy, we don't have any other redundancy. We are having only striping option. There is no mirroring option. Okay, whatever the data you are going to write it, that will be there. Suppose that this group is failed, you will lose your data, right? Then why we need to use and where we are going to use? What are all the advantages? Okay. Instead of normal. Normally, by default, each and every organization, they used to use normal redundancy. Okay, this is the point you have to note it down. High redundancy, very, very rarely people will be used because they require, suppose 1 TB data, 1 terabytes of data they need to store. Here, if they are using one high redundancy for that 1 terabyte data, they require 3 terabytes of storage, 3 terabytes. But if they are using the same 1 terabyte data, in normal redundancy, they require 2 terabytes of storage. But in case of external redundancy, they require only 1 terabyte storage is fine to store your 1 terabyte data. That is the difference. Okay. Then why we need to use this and where and advantages of your external redundancy, right? Cost efficiency. If you want to store 1 terabyte of data, external redundancy, it will take only 1 terabyte of storage. But in case of normal redundancy, you require 2 terabytes of storage. So we are going to reduce the cost when you are using external redundancy. Storage system integration. That's very easy to maintain your snapshots whenever you are going to take the backups. It's very fast compared to normal and high redundancy scenarios. Reduce the overhead and CPU memory if they want to access, right? We can reduce the overhead of that. Flexibility and simplify the configuration. So if you want to go through the definition of each and everything, you can pause this video and go through these definitions. But for this question, you can say, if somebody will ask you, And what is the use of external redundancy and the advantages or advantages of external redundancy? You can say cost effective storage system integration will be helpful, reducing the overhead of this, managing and other things, simplify the configuration and flexibility. Next question. How to copy files from ASM to normal file system, or how to copy a files from ASM to normal file system, to ASM from normal file system, vice versa, simple thing. If you are using non-ASM file system, here we can take two. Okay, let me take it. Control it, delete it. Let me take it this. Okay, here it is. So if you are using two different file system, one is ASM file system, another one is non-ASM file system. Non-ASM file system. Different. If you want to copy a file from ASM to non-ASM file system, how you want to do it? If you want to do non-ASM file system to ASM file system, how you want to do it? Or if you want to take the copy of the file from your ASM disk to local file system, okay, locally. ASM is wherever you are going to use it, disk groups like data plus sign will be there, right? Data to your normal U01 mount point or U02 mount point or backup mount points, right? From data to U01 or U02 mount point, how you are going to copy, and from U01 data to ASM, how you are going to copy. That is the question if somebody will ask you. You can use ASM CMD is the command where you can copy the data from here and there. Two different way you can use it. ASM CMD, use the copy, complete path, and then give the disk group location. In this way, you can do it. Again, from ASM disk group to local, you can give the local path. These two commands, you can use it, and then you can do it straightforward. Okay. Then how to find out the databases which are using ASM instance? Very simple. As and when you are connecting to the database, SQL plus as ASM or SQL plus, use this command $ASM client, or else you can connect to ASM CMD is the utility or command line. CMD is the command line tool, and there you can use LSCT. It will give you that information. We can able to find out which are using the ASM instances and all. Those two commands we can use it. Next one, what are all the different types of stripings and mirroring kind of are stripings in ASM and their differences? So we used to have two different types of striping. One is coarse striping, Coursera striping, I can say Coursera, and is fine striping. So striping means writing the data into your disk groups, right? There are two types. In your striping methods are two types. One is Coursera striping, another one is fine grained or fine striping, we can say it. So why we need to use this, where we are going to use it, and why we are going to differentiate, how we are going to differentiate Coursera striping and fine striping. This, whatever the data files and backups, okay, normal data files you are going to use it, right? Those data files and backups where you are going to store it are using Coursera striping will coming to the picture. For this, your data files and backups. For redo log files, current transactions, whatever you are going to write it, fine striping is a crucial role. It will write your information into your redo log files. Okay, these two are the differences. Very simple way. And if you want to differentiate Coursera striping and the fine striping things, you can see it. Striping size larger than 1 MB, and if it is a smaller one is 128 KB data, it is going to write it. For Coursera striping, it is using all the data files it will be used, and control files, archive log files also it is going to use Coursera. Large sequential IO, but it's a redo log files. It is archives and redo logs. You have to differentiate, okay? Two different things. Redo log files, small random IO files. Only small in KB's data it is going to write in your fine striping. Performance sequence IO operations optimizing large. The small and frequent IOs will be there. Okay. These two will be the difference, high level differences. And more data is there, that is more than enough. We don't need to go for all this data. If you want, you can pause the video and read it, everything. Fine striping information. And here it is, the coarse striping information. Okay, you can pause it and then you can read this definition. I don't need to, no need to extend this video length and all, right? Next question. What happens if you miss this plus symbol, plus sign, while you're adding the data file into your disk, ASM disk groups, right? Sometimes few of the junior DBAs, they are going to use it. They don't know the importance of this plus symbol, right? In ASM, whatever the things we are going to use it, it should be start with your disk group plus data, plus archive, plus redo, and plus the custom name, whatever they are going to give it. That belonging to your ASM. We are thinking about like plus is belonging to your ASM related things. See here, plus sign is used to indicate that the file is being placed in ASM disk groups. Okay, being to placed in your ASM disk groups. If you miss the plus sign while adding the data file, that will be interrupted. That will not store in a proper path. That will not located or placed in your correct location. That will lead to issue of your data files assignment, right? So you may face or you may see this kind of error creating the data file or different scenarios. For that, you have to use proper command to add a data file to these scopes. By using this command, you can able to use it. So for this question, if somebody is trying to miss or adding the data file, they missed the plus sign to that the command, okay, then they will get this error, or a 01119 error or 27040 error. Next question. This is very important. What is the allocation unit, AU, and what is the default value for your AU size, and how we are going to change it? So these are three questions included in one part to understanding purpose, right? Why we are going to use AU and all. When you are going to use LSDG and clear-cut information of your disk groups and everything, you can see this AU size 1 MB will be there, 4 MB will be there. So why we need to use those things? What is mean by the AU, right? Every ASM disk is divided into AU allocation. Each disk is divided into allocation units. Okay. AU is a fundamental unit of allocation within a disk group. It's a fundamental allocation unit, fundamental unit of allocation. AU means fundamental unit of allocation. A file extent consists of one or more AUs, allocation units. ASM file consists of one or more file extents. So it's a continuous, or to understanding this, you should have to go with complete ASM related video, which we have placed in our previous. You can go through and you can understand that. Okay, or else you can comment it. I'll check and then I'll give you more clarity on it. Okay, simple, like even in our data files also, if you want to understand the data file, right, or table space thing, how the table space will be, the collection of segments, we call it as a table space. How we are going, what is the segment, extensions, the collection of extensions, we call it as a segment. How the extension will be happen, the collection of or sequential blocks or collection of data blocks, we call it as an extension. Or sequential blocks, we call it as collection of sequential blocks, we call it as an extension. And what is the block? It is the smallest part in your database. It could be 2K size or 4K size, 8K size, 16K size, each block. So the collection of these blocks, we call it as an extension. The collection of extensions, we call it as a segment. The collection of these segments, we call it as a table space. That's it, right? The same way in ASM, we call it as this AU also. You can go through it in this way. Okay, ASM disk is divided into allocation units, and the fundamental unit of allocations within the disk group, we call it as a AU. AU is definition is this one. A file extension, a file extent consists of one or more AUs. So this is the definition of AU, and how the AU is, how the AU will be defined in your ASM. If you want to see the unit size, like allocation unit size, you can go through the name allocation unit size from the $ASM underscore disk group view. So if you want to modify, okay, if you want to modify the allocation unit size from 32 MB to 16 MB or 8 MB, by using this command, you can modify the allocation unit. See, if you want to see the allocation unit size From the command ASM CMD command prompt, you can use this. Let me give the ASM CMD. From this command prompt, you can use LSDZ. You can see it, or else SQL plus as sysasm. From connecting to sysasm, and then you can use this select SQL. Here also you can able to find out. That's it. Next question, what are the background process in ASM? Very, very important, right? Normally, what are all the important background process in Oracle database? We used to get it, right? Those kind of questions. So same way for ASM also, we have important background processes. These background process will help to maintain your ASM file system. Okay, ASM file system. So what are all the mandatory, they will ask, or else what are all the background process in ASM also they used to ask, but you should have the information of background process about your ASM things. Okay, Oracle ASM has several background processes. Out of those several background processes, we are going to talk about 2 or 3 mandatory background processes or important background processes of ASM. So these background processes will help, okay, to storage management, file and disk group management, and data redundancy, to store the data in different groups, right? To manage all those things, these background processes will be helpful. Okay. Then what are all the background processes? Here is the list of the background process. First one is ASMB. ASMB is one of the background process. This will help all the communication between your ASM instance and the database instance. In between the database and ASM instance, the communication will handle by this ASMB, one of the background process. It's very, very important. And the next one is RBAL, rebalancing. This is the background process. It will help to coordinate the rebalancing activity within ASM instance. Why we need to what is this rebalancing and all? Rebalancing means whatever the data disks storage we are going to add it, the storage will be added into all the disks with the same size, okay, with the same quantity. Who will do that? That is done by the RBAL background process. So RBAL will coordinate the rebalancing activity within the ASM instance. That is another background process. Third one, ARBN. ARBN. This is the actual rebalancing. When this is going to initiate the rebalancing operation, background, this will work. How this ARBN will be configured and how the ARBN process will allocate according to this parameter, ASM power limit. If you are giving 1, okay, only one ARBN process will do the actual rebalancing. If you are giving ASM power limit 11, so ARBN 1 to 11, those 11 processes will do the rebalancing very faster. So ARBN, see here, where n range can from 0 to 9, okay, run concurrently depending on the load and configurations. So if you are using more value, that will be work on a more or faster way to do the rebalancing. Other background processes also there. We are not going to discuss those things. Gmon also will be there. Monitoring the status of all the ASM disks. This is one of the important background process. Mark also there. All AU allocation units for resync. This will helpful. And RSMN also there. Resynchronization. XDB is there. Elmon is there. ASM Elmon. Normal Elmon is there, and also ASM Elmon is there. LFD is there. These are all the background process, but very high level important is ASMB, ARBN, ARBN, this one, and rebalancing one, RBAL, RBAL, ASMB, ARBN. These 3 are the high level important background process. There are a couple of like important these many things. And the next question, which background process does the rebalancing? Just now we gone through it, right? RBAL and ARBN will take care of the rebalancing thing. So depends upon your ASM power limit, the rebalancing will be the faster one. Inside of these things, Gman and Mark also will provide you the, those will help this RBAL and ARBN for rebalancing activity. So rebalancing, you can increase the value by using this command, alter disk group name, rebalancing power limit, how much value you want to give, you can give it to that. Then how to dismount the ASM disk groups from particular instance in a rack. When you're using a rack environment, how you are going to dismount a particular disk group. Okay, any maintenance activity is there. At that time, how you're going to put a dismount. So you can use SQL command. First, check the status of the disk group. Okay, suppose in my case, my disk group name is the data. Okay, this data is my disk group name. I want to see that. So you can dismount. How we are going to do that? By using srvctl command, you can do that. This is a command, srvctl stop asm hyphen disk group name. You can give, okay, hyphen node, and which node. If you are using 2 node or 3 node or 4 node, give the node name. Okay, then on a specific node, this disk group, data disk group, is going to stop or dismounted. SQL plus is, or you can connect it to sysasm and do this part, alter disk group, data disk, and dismount. In this way, you can go ahead and do the dismount of that. 2 ways we can do it. Then this is also frequently asked interview question. Frequently asked interview question: how to add a disk to disk group, or how to remove a disk from the disk group. So 2 questions in this single question: how to add disk to disk group, how to remove disk from disk group. So these 2 questions, if somebody will ask you as part of that interview, you can just check ASM disk group status, okay, and ASM disk. By using these 2 views, you can see the status of those disks and disk groups status. Then you can use alter disk group name, add disk, give the path that will be added, okay, or else you can give it here. This is your disk where you, which disk you want to add to this disk group, okay, the disk location you have to give it, alter disk group name, add disk, that you this in this way also, disk 3, disk 4, or this way also you can give it. These 2 ways you can able to give that. And check the rebalancing. Once you, as and when you add a disk or remove a disk from disk group, rebalancing will happen, okay. Once you're done with this command, immediately you can use this command, $asm operation command. You can check the rebalancing status. Okay. Now how we are going to drop a disk from disk group? Alter disk group name, drop disk and the disk name. Which disk you want to remove, you can do that by using SQL plus as this ASM connect and do this, or ASM CMD also you can execute this command. SQL plus sys ASM and do this, or SQL here or here using connect to ASM CMD, $ASM CMD, then execute this command. Either this or this, 2 ways you can do. Last question for this video, we are going to see how the rebalancing will work. What is the flow of rebalancing? Okay, we talk about ASM power limit will help to rebalancing quicker, and we talked about ASM B and RBAL. ARBN will take care of the rebalancing, right? RBAL and ARBN will take care of rebalancing. How the flow will be there, okay? How the rebalancing will happen, complete. First one, the rebalancing operation is once it is initiated, when a disk is added or removed or fails in ASM disk group, first background process, Gman process, will detect the changes, whether it's added or removed, that will be monitored or detected by this background process. And then it is going to give the signals to your RBAL. One from this Gman, it received the signal, something happened, it is an add, disk is added. Then RBAL will take over that and then coordinate with your ARBN process. And then this ARBN process will take care of that distribution. Whether it is added or when it is removed, it will take care of it. So this is the flow. Gman will monitor and then initiate the RBAL. RBAL will take care of the and coordinate with ARBN, and ARBN will actually performing the rebalancing. Throughout the rebalancing operation, Gman and RBAL monitoring the progress. If any issues arise, such a disk failure or rebalancing and the process adjustments according to this, it will do the integrity and continuation of that operation. So this is the flow how the rebalancing will work in ASM. So these are all the interview questions. So most of them we have covered. And yeah, if any other questions, if you feel some question answers required, comment it so that I can make another video. Okay, thank you so much. Have a great day.